Okay, so the next candidate for Big Red here is our stump adjusters. We're going to be pulling on the top of the stump adjuster, simulating when, if there's a storm or that and your house is literally being lifted up by the storm, how strong are those little Tek screws that are holding your stump adjuster to the top of the stump. Now the stump itself, we know, an average 90 by 90 stump, if we put it in here and we pulled in the middle of it over 600 millimeters and it collapsed and bent at 3 ton, I think. Yep. And so we know that, but so much more weight than 3 ton, and the steel itself is likely to bend. So if those little Tek screws can hold 3 ton, then good as gold. But we're going to see how much they hold until they break. So now let me show you around. Now this is our adjustable stump here. You can see the thread there. You can adjust your house up or down with it. We've put this chain on it to start pulling on it. Our design though has got 2 Tek screws here, 2 Tek screws here, and we've actually got an insert in the middle of the stump, right, that this Tek screw goes through into, right, and there's a 3mm plate on the inside. And we'll test this for lateral strength another time, but today we're just testing how strong if you put all 4 on this side, 4 on the other side, and 2 in the middle, so 10 Tek screws. If you put all 10 Tek screws in to the stump, how strong is it at just physically holding that weight of the house pulling up on it, or even like it'll tell us something anyway. So here we go. We got the 118 kilos on our adjustable stump top now on those 10 screws, and we've got it welded on down the bottom there. It's all good to go. Actually, that's a better angle there. Look at that. Yep. All right. That's our setup. There's our gauge. Up the top is our 12-ton jack. So now let's see how much weight we can put on those 10 Tek screws. So 10 Tek screws, according to the manual, will take 400 kilos each. So it should take 4 ton, but we'll see. And maybe 10 screws together takes more weight than 10 screws individually. 700 kilos. Don't try this at home, boys and girls. We're trained professionals. Don't try this at home. Yeah. 1 ton. Okay, it's getting hard to jack that. 1300 kilos. Gonna need a bigger lever on my jack, mate. There we go. I'll slide the lever out a bit more. 1600 kilos. Yeah, that's not too bad, right? Like I said, at 3 ton, when we tested the steel across here, we put a piece of that 90 by 90 steel across here, and we put the chains around it and pulled up on it. And at 3 ton, it started to kink and fail, right? So we've got 1700 kilos on this now on 10 Tek screws. I don't know whether this fails violently or whether it just kind of breaks gently, but we'll find out. Might scare the bejesus out of me. What a weird saying. Anyway, so we're getting to the point at which the steel stumps might be starting to fail if this was on a house. Because that's 2.5 ton pulling straight up on those 10 Tek screws. Now, as opposed to tops that are welded on, like adjustable stump tops that are welded on, I don't know whether they'd perform much better. I've seen lots of tradies do welds, and they look like good welds, and they're just slag holding them on. So maybe this is maybe this is better to put Tek screws in. But anyway, there we go. 3 ton, mate. I need a break. All right, 3 ton. That's so that's at the point now where where when we put that piece of steel in there, across this distance here, which is 600 wide, put a chain through the middle of it, that piece of steel, that 90 by 90, bent in the middle. And that's your standard 90 by 90 house stump there, right? Now, of course, you've got 75 by 75. Obviously, they'd bend it a lot lower, and obviously, this is only 600 wide. In the middle, it's only 300 from the top. So maybe, you know, like if you've got a 5 metre long stump, not that you would, but obviously the longer it is, the more leverage you've got, the lower amount of weight you've got to put in the middle of that to break it, right? Anyway, so that's all of the science stuff. Now it looks like the steel gives a little bit and it goes down. We saw that when we bent it, but let's keep putting some weight on that and see where we get to. Mate, it's starting to groan now, I think. We might break big red here. 3.5 tonne. Mate, that's really hard pulling on that lever. So 4 tonne. So that's 100 kilos per tech screw at the moment of shear strength. Right, I've got to change positions because this is hard work. Uh, 4.5 tonne. Mate. I don't think I'm going to get up to the 10 tonne we need. All right. Anyway, what's it looking like on this post? Anyway, just come around here. One shot. There we go. Okay, so yeah, still looking like it's got 5 tonne on it, and it's just pulled up that tiny little bit there by the looks of it. I won't put my fingers in it, but those tech screws are still holding on good. All right, and it's 4 tonne, 800 kilos of weight on that. So if you're wondering how good tech screws are at holding weight, 10 tech screws in this is holding 5 tonne of shear strength. And yeah, and it might actually, I'm not an engineer, but it looks like the tonnage, it was up to 5 there before, and it looks like it's coming down. So it might be that those screws are bending slightly, and so as they bend up, they might be just shearing. So this might be 5 tonne over a certain time frame that it holds the weight, and those screws might be just slowly cutting off at that. I don't know, but what I do know is over 3 tonne or thereabouts, that was what the steel itself bent in. So 10 screws is stronger than the 90 by 90 mil steel. Anyway, let's keep going on this and see what we've got. 5 tonne. 5.5 tonne. Hey. Oh. Okay, so 5.5 tonne, and one side broke. Look at that. So the tech screw's all sheared off at 5.5 tonne there. Right, on the one side. The other side's still holding on, right? And this is 8 mil steel on ours, and you can see it's kinked sideways and bent. So obviously these two in the middle have bent as well, and that released all the pressure, and then these ones have just stayed on there. So anyway, that gives you a really good idea of how much strength these tops will handle. Obviously our top itself didn't break. It bent when the screws gave way. So you know, that's a good sign for our tops. They handled 5 tonne of upward pressure on that top, which I had no doubt I'd got no, you know, that's a 33mm screw up through the middle of that, and an 8mm steel, there's and a 10mm top on it. I don't think you're going to break that any day, but it gives you a good idea of the tech screws. The tech screws broke at 5 ton, or just a bit over. So for 10 tech screws. Now, some of the tops on the market, they only put 4 tech screws in them, 2 in from each side. And, you know, I guess we can test 4 screws, see how much 4 screws takes, but you know, if you just did the numbers, 10 screws takes 5 ton. What's that? 500 kilos a screw. So 4 screws is only going to take 2 ton, I guess. You know, might work like that, might not. Might be a different number. But if you said that, then 2 ton is less than the breaking strength of the steel, so the screws become the weak spot. Anyway, that's me. If you want some stump adjusters or some adjustable tops for levelling your house out, you know, our tops are strong as. Yeah. So see the bend in that tech screw. They were taking a lot of weight coming out of there. How's the next one come out? According to the book, they reckon, I reckon 400 kilos per screw. So 10 screws would be 4 ton. So it didn't break until 5 ton. So the book's pretty right, hey? So well done. So that's the 4 on that side that broke off, and they've just sheared straight off of there, right? But we didn't put the bolt in the bottom, right? Now we've got a bolt hole there in our adjustable tops. This is the bent top, right? And see that plate insert that goes inside the stump there, right? So that goes inside your stump, right? So that makes it really strong compared to other adjustable tops that don't have an insert as well as an external. Now, if I turn this way and just show you here, that's got a bolt hole there as well. Now we didn't put the bolt in, but we're going to do a test with just the bolt and see how strong that is, and whether the steel bends or it cuts through the steel, or whether it gets up to 5 ton like the tech screws do with one bolt. Okay, so here's our adjustable stump top on top of a simulated stump again, right? And we're with Big Red, and we're going to test this for the bolt strength. We just finished testing the screw strength, but we want to know whether if you just put one bolt in, is it as strong as if you don't. Now please forgive this stump top, because this one here, we haven't had it galvanised or zinc plated. We just spray painted it for the purposes of smashing it, and so yeah, if you buy them, they'll be zinc plated or galvanised, up to you. Anyway, but we're going to put it in Big Red and smash it. Okay, so we've got our adjustable stump top in Big Red again, and you can see, you know, we've only got the one bolt in the bottom now, and we're just going to see. We tested with the screws. The screws broke and sheared off at 5 and a bit ton, right? And we just want to see how strong one bolt is. Now I anticipate that it's going to cut the steel, right? And so it'll, but we want to know how much weight it takes before it does. But we'll see. All right. I don't anticipate the bolt breaking. All right, so let's get up here and get to it. I might move that. Okay, so here we go. 600 kilos, 700 kilos, 1 ton, 1.5 ton. If it takes more than 5 ton, then you know one bolt is stronger than the screws. We're up to 3 ton. All right, let's see. Four ton. See, I think it just moved there. Did it move, Tang? It's come up, yeah. So So it got up to 4 tonne, and then it's released a bit of the pressure and come back 400 kilos, and that's because the actual top, like I said, is tearing in the steel and lifting up. See, it's actually starting to lift up in the steel. So this is the bolts actually tearing in the stump steel. So at 4 tonne, it starts to tear. Well, to put that into context, a lot of the manufacturers of stump tops only say that you need to tech screw them in, and they only provide you with 4 holes to tech screw them on with. You know, some of them might have 2 holes on each side of the box, and so there's 8 screws. Right? Our adjustable stump top's got a position for 10 screws. But so putting it into context with the bolt started to tear the steel at 4 tonne. Right? That's still probably pretty good. I'm not an engineer, but I don't know how much upward force each stump has to take. But this one right now, it was up to 4 tonne, and then it started to tear. Now, the good thing about a bolt maybe is that when it starts to tear the steel at 4 tonne, it doesn't just shear off and your house isn't bolted down anymore. The house is still bolted down, and it's just about a centimetre higher because the stump's pulling up, right? So maybe that's an advantage rather than have tech screws that shear off. I'm imagining that you don't want either situation to happen, but putting a bolt in with the tech screws, that might be the ultimate combination. Then you'd have the shear strength of the screws, and the fact that if it did break, your bolt's going to hold 4 tonne by itself. Okay, we've just pulled the bolt out of that, and you can see that bolt still pretty good, but you can see the cut in the bolt from the steel as we put 4 tonne of weight on it on each side. So, and then it just started to cut this steel. Now, because of our insert in the middle and in the top here, it can't twist off of that yet, right? Even if it comes up a little bit, it's got to come up past that insert in order to get off the post, as it were. But let's have a look at these holes now. So see, that's how the hole has just elongated, and it started doing that at 4 tonne. We'll check the video, but you can put 4 tonne of upward pressure on that bolt before it starts to fail, and 5 tonne for 10 tech screws. So maybe put the screw in with the bolts if you're in a cyclone area. I don't know. Up to you. Actually, another point to note is this elongated here at 4 tonne with the bolt in it, but this here is not maybe the size stump that you might use. It's 90 by 90, but it's only 1.8 mil thick, and maybe your house stumps at 90 by 90 would normally be 3 or 4 mil, right? And if you've got a high up house, they might be thicker than that even. But we were testing the bottom standard size, right? So the smallest size that you might have, right? This will still hold 4 tonne on this bolt. How big is this bolt, mate? 12 mil? Yeah, so it's a 12 mil bolt, and so it'll take 4 tonne before it starts to fail and elongate this steel out. Right? And like I said, though, as opposed to the tech screws that shear off and then potentially your house flies away, the bolt is taking 4 tonne at that point, and it take 4 tonne all the way up. So maybe that like in a gust of wind, maybe it only elongates a little bit, and then your house comes back down, and maybe that's better than tech screws that shear off. Now, it might also be better than a weld, so we'll test a weld yet, and we'll find out how strong the welds are at the top. We're just screwing this stump top back on to do a lateral strength test on it, and it's got 10 screws in the top normally, so it'll be interesting to see how strong it is with a lateral strength test. And if you're underneath a house, welding stump tops on is normally a bit harder to drag a welder around under a house. You know, there's a risk of a fire underneath the house with a welder. You know, risk of somebody burning themselves or you know, setting fire to some of the leaves that are underneath houses or things like that. And so tech screwing stump tops on might be a good idea. Yeah. Might be a good idea as opposed to welding them on, but that's why we're doing the test. Either way though, with our stump top, because of the design, you can put a beater weld along here, along the top, you know, all over it. So it's a lot stronger design than what most of the stump tops on the market are. And also it's got this tab in the middle now. Excuse our holes in this. We've been testing with this same piece of stump half the day, so it's a bit damaged from our other tests, but we've turned it sideways, so we've got new holes for putting these new tech screws in to do a sideways strength test on it. And this is screwing through the 2 plates of steel, the stump plus the 3mm steel on the inside. And so as you can see, not too hard to do that. But the thing to note is that these screws are a little bit longer and they actually jam against your shaft, right? So that could act as a locking mechanism to lock your shaft in place and stop somebody adjusting it, you know, just with a couple of spanners some other time without knowing to undo those screws. Okay, so it's the end of the day, and at the end of the day, testing gets a bit, you know, cowboyish. But so I know that, but I really want to find out what lateral strength I can put on these stump tops today. It's nearly Tet holiday here, so tomorrow we're off for a week. So I want to not be thinking about it for a whole week and just be like, yes, it made 4 ton of lateral strength or 2 ton, whatever it made. So anyway, let's put it under the test and we'll see how these stump tops go. So we've got this this set up here, and this is our adjustable top extended out 150 millimeters. So it's 150 millimeters from here to there. Now I realise that the chain takes a bit of that off, you know, so it's not bending it, but we want to find out whether A, this 33 millimeter bar bends before these shear off, or that these tech screws, 10 tech screws in the adjustable top actually held 5 ton when we were pulling straight up on it for shear strength. So on a lateral strength test, you know, we don't know, maybe it holds 5 ton as well. The difference though is that unlike a lot of adjustable tops that have got a skirt down here, ours has only got one on one side, one on the other side, and it looks a bit nicer. It's a bit easier to install, and it gives you more place to weld. Like you can weld all the way along here with a down weld and a cross weld here, you know, so you know, it potentially is a lot stronger, and we can put a bolt in the bottom as well. So and it's got these little 3mm skirts welded onto the inside of the stump, not to the stump itself, but to the top of this plate. There's a 3mm skirt, so that's stopping this pulling up, right? There's no way it's going to break those 3mm plates off before it breaks this stump itself. So anyway, let's put some weight on it. We've got the other end jerry rigged down, so hopefully that hopefully that lets us put some weight on here. Okay, so we're just going to start jacking this up and see whether it takes any sideways strength on this stump top. So that's 170 kilos, right? So we're imagining that this has got a house bolted on here, and there's the wind pushing on the side of it, and that's the stump going down there and into the ground, right? And we've got this hooked up on our machine here at the moment. And so let's see, we've got now we've only got 10 tech screws holding that stump top on. It's not welded on or anything like that. So, and those Tech screws, they sheared off. We had a shear strength of 5 ton when we pulled up on them, right? Now, is that bending that shaft there at all now? No? No. Of course it's not going to bend it, right? It's only 500 kilos, right? Okay, let's keep going. 700 kilos. Now, I don't exactly know how much lateral force you need to be able to put on a stump top to meet the standards. Right? If you're an engineer, put it in the comments. I'm sure there's different situations for different areas and wind ratings and how many stumps you got under the house and all of those things. But just as a general guide, is 1 ton of lateral strength good enough? Because this has got 1 ton on it and our screws haven't broken yet. Our Tech screws, we've got 8 Tech screws there, so you'd expect maybe there's 4 in their sand, so they're 400 kilos thereabouts each for a Tech screw. So I reckon 1.6 ton and these Tech screws at the back might break, but we'll see. Now, of course, my stump top here, we could actually put a bolt through the bottom too, and that would make all of this a lot stronger. And this is pulling sideways on the top, on the weakest part of it, right? So if we had it around the other way, it'd be a bit stronger than this. Right. There we go, 1.2 ton. Pretty strong. Right. If you got 20 stumps under your house, or 30 stumps under your house, I guess there's 30 under most houses that are small, and you got 1.5 ton, that's a wind pressure of 30 or 40 tons, right? That's probably all you need, I don't know. And that's at the maximum height for this adjuster. So 1.4 tons. Now, like I said, I predicted 1.6 tons before those Tech screws at the back shear off. Oh, there we go, 1.4. Did that break them? No, it doesn't look like it's broken anything. Hang on. Oh, it might have, yeah. Has that? Yeah, I think it has. I thought it might have just been the chain slipping, but I think that's just broken those. So it's sheared those back Tech screws off. We'll just put a bit more weight on it and see, make sure that that's the case. It's still got a ton of weight there, but I reckon that's. So we got up to 1.5 tons before our back screws sheared off. Let's keep putting some weight on it and see what happens from here. Now, of course, if we had a bolt in the back, it'd probably handle that a lot better. Yeah, back up to 1.5. There we go. Oh, 1.5 tons and broke again. Okay, so 1.5 tons of sideways lateral strength at full adjustment out, right, before it shears. Now, that wouldn't be a problem if we had a bolt through the bottom, right, as far as lateral strength goes. But, you know, that's why we do the test, and find out what the machine or what the stump top will handle. And I don't think there's anybody else producing stump tops that are actually showing their tests like this as a real world. Well, this isn't real world, but it's you know, a really easy to see example of what happens when you apply pressure to these things. Okay, so this is our stump top as we just pulled it out, and you can see it's sheared off these 4 screws on the bottom side of the stump adjuster. These other ones are still holding on, but just roll him over. Just roll this over, mate, and over the other side, right? Okay, and see this. The actual steel has bent, right? So we had our support here across on the steel, right? It actually bent the steel itself. So that's the thing, is that this failed, but your house stump itself might have failed too. You know, like mind you, this is 1.8 mil by 90 by 90, right? RHS. So maybe you got thicker stumps than that. But anyway, we're going to put a bolt in the bottom now and try it with a bolt. Okay, it's beer o'clock in Vietnam, and I've got it all set up again with our adjustable stump and with the lateral strength test. And so we're pulling on the side of the stump, and we've just got one bolt in it down the bottom. And so just with one bolt, we're just going to see how strong the stump is. Now, really, I think that it'll take the 4 ton that the bolt takes to tear the steel, but we'll see. So here it is, all set up, ready to go. You can see the one bolt in that end there, right? We don't have any tech screws in it this time at all, and the stumps in our machine. We've got the other end of it tied on, and so we're just going to put some weight on it and see how strong it is laterally for just one bolt. Now it's actually adjusted out 150 millimeters. Last time it didn't bend that bar at all with 1.6 ton on it, but it sheared off the bottom tech screws. Now with that one bolt, I don't think it's going to shear off. I don't think it's going to bend or anything, but we'll see. That's the whole point of testing things. 700 kilos, 800 kilos. Now we've got steel inserts in the top of that stump there, right? That are 40 mil long, 3 mil thick steel inserts, and that's what's actually holding this end of the adjuster on the stump, right? So one bolt down the bottom and the steel inserts. Now we haven't got them screwed on at all, and you know, I wouldn't recommend that if you're putting them on the house, but you know, it's a good test. So 1.3 ton. Now I think that we're tearing the steel there. So 1.3 ton, we're actually tearing the steel at the top of this stump adjuster, right? The bolt's not tearing, but the top of the stump is tearing. So that's where having that insert in the top of your stump. Now this stump's only 1.8 millimeters wide, so it's going to deform and tear a lot quicker than like maybe a normal house stump would. You know, depending on your engineering design, your house stump might be 3 mil or 5 mil thick, but even a 1.8 mil thick one has got 1.2 ton on it sideways, and it's still holding on the house. So if there was a cyclone blowing on your house, you know, you know, this stump's going to fail. So obviously we should test it with a thicker walled stump, because this isn't good enough. Okay, thanks for watching. That's our stump adjusters and tested. And I mean, if you want to order some, let us know. We'll export them anywhere in the world, America or Europe or that. And they're a very cost-effective solution to adjusting your house, rather than just welding a static top on, or the normal type stump tops. These ones here are really flexible. Bolt them on, screw them on, weld them on, and they're really strong with the 33 mil shaft, threaded bar up the middle on the 90 by 90. On the 75s we've got 30 mil shaft up through the middle, and they're an 8 mil steel plate that's folded, so it's really strong.